So today we're doing 2-4% of change. Here's the definition of percent of change. Percent of change is a ratio that compares the change in quantity to the original amount. It's a ratio that compares the change in quantity to the original amount. So we did a lot of ratio and proportions last chapter. And we're still continuing to look at ratios. When you guys see the word change, what do you think change in math? What does change tell you to do in math, in a math problem? Change what? Change it from one thing to another. What about in like operations, the operations of math? What do you think you're going to do? You know what the operations are? Add, subtract, multiply, divide. What do you think?
Change.
Percent, yeah. What else?
I think it's like division and multiplication.
Okay, so she's like thinking I'm going to divide or multiply. Anybody else? Yeah.
I think of like gems, or like gems.
Oh, okay, yeah. Change. So how something changes. How can you find how something changes? Like say today is 83 degrees and tomorrow's 85 degrees. How do I find the change in temperature? Subtract, right? Okay, what if today is, or what if I want to find out last year I made $3 an hour, because you know I'm a teacher, right? $3 an hour, and this year I'm going to make $3.50 an hour. How do I find that out?
Is that true? Subtract.
Subtract. Do you notice I'm subtracting a lot when I do these? Okay, that's a little hint. All right, so here's another thing. We have a percent of increase, and that's when the original amount increases. You also have a percent of decrease. Similar, but it's when the percentage decreases. So we're not just going to look at numbers like, oh, my salary went up 50 cents. We're going to look at the percent my salary changed, or the percent the temperature changed, okay? Percent of increase when the original increases, so that'd be like my original salary, or maybe the temperature, or maybe when it decreases, maybe you could say, I don't know, if you're losing weight or something like that, you could calculate your percent of how much weight you lost. You could, what if you had a really good baseball season last year and this year you didn't? Because you're growing and you're awkward now, right? So you could calculate your batting average percent decrease. Things like that. All right, so there's some magic formulas. So I actually wrote them as magic formulas. These are magic. Magic formulas. The percent increase is equal to the amount of increase over the original amount, meaning divided by, right? This is how we calculate the percent increase. Okay, so if I wanted to calculate my raise, I would say, okay, well, the amount of increase was how much? I went from 3 to 350. So what's that? 50 cents, right?
Yeah.
Over the original amount, which was $3. Okay? So pretty basic math right there. And the percent of decrease is pretty much the same thing. Doesn't change a whole lot. So you notice both of them are over the original amount, the starting amount, right? Yeah. That's not going to change when we do these. Just the number, the amount of increase or the amount of decrease will change. And we get that by subtracting, right? Subtracting. So we're always subtracting and we're always dividing by the original amount. That's never going to change. Yeah?
It's kind of like how you're setting it up is kind of in a fraction.
Right, a ratio.
Are we going to divide it?
Yes.
Okay.
Always dividing by the original amount. Okay? So here's an example. Find the percent of change in the cost of gasoline from 1970 to 2010. This is 40 years. We're going to find it. Do you think it went up or down?
Went up.
Yeah. And even more since 2010, but
Like $3.
okay? So here's the prices. Here's the prices. All this information would be given to you. Let me zoom this in for you guys in the back. Okay, so we have that in 1970 it was $1.30 a gallon, and in 2010 it's $2.95 a gallon. So that was more. It's more now. It's like $3.30 right now. No, it's low. It's a little low right now. It's gone up to over $4 though. The last couple of years it was over $4 a gallon. Yeah. It's sad when the gas costs more than what I make an hour, huh?
Economy is getting crazy.
Where is $7?
I know. I'm just calculating the actual hours I work, which is more than 40, right? The hours they pay me for, and then the other hours I volunteer, right? Yeah. Okay, so we have this change in price. How should I calculate the change? Subtract the $2.95 minus the $1.30, right? Okay? So I subtract. So that's step one. Step one is you subtract. It's always going to be step one. Step one doesn't change. It's still subtracting. So I get $1.65. So has it gone up or down $1.65?
It's gone
Up. Good. Just checking to make sure you're awake. Now I take that and I put it over the original amount. What's the original amount?
130.
Good. Okay? And then when you do that, you're going to get some sort of decimal. But the last step is to turn it into a percentage. So I'm going to get the 1.65, which is $1.65, over the 1.30, which was the $1.30 of the original amount. And I get 1.27 when I put that in my calculator. Your calculator sounds like mine, right? Does it do that? And then I get 1.27. But now here's the problem. Some of you are like, I don't know what to do with the 1.27. Because you forget how to put your decimals into percentages, don't you? But it's two places to the right. So if you're going from decimal to percent, 2 places to the right. From percent to decimal, 2 places to the left. Right? It's always moving it 2 places. Yeah.
But isn't that only one place?
Yeah.
Oh, you're right. I did that one. What did I do?
But you moved it once.
I only moved it once. Why did I do that?
What?
Probably because I was doing this last night at like 8 o'clock at night.
Because you were tired.
Let me just check my calculator.
For which one?
1.65 divided by 1.3 equals 1.269. So it should be 127%.
Yeah.
Silly me. Good thing you caught it. Maybe you guys should help me write these notes at 8 o'clock at night, yeah? Who wants to come back to work at 8 o'clock at night right now?
Sure. Why not?
No, it's volunteer hours. Those are the volunteer hours.
No, I'm okay.
All right. Good catch there. 2 places to the right would be 127%. Now, does that sound like a big number?
Yes.
Like a lot to increase?
Yeah.
Yes. Okay? So some people get a big number and they're like, oh, that can't be right. But it can be, because if it more than doubles, right? The gas price more than doubled, right? It went from $1.30 to almost $3. That's more than doubled. So if it's more than doubled, it's going to be over 100%, right? Yeah.
Can you repeat like which way you move the decimal?
Sure.
So I can-
So, okay, so the decimal, right? If you start with the decimal, like all these, you're going to get a decimal. You go 2 places to the right to get the percentage, which is what I didn't do, and then you guys caught me. You kind of caught me. Okay? If you get a percent, then you go 2 places to the left. But in this case, we're getting decimals, so we're going to the right. Okay? Percent is to the left. Decimals to the right.
Decimals to the left.
Okay.
To the right.
So look, 55% as a decimal is 0.55. 0.45 as a percent is 45%.
Oh.
2 places.
I got
Okay? All right. What about 8 point? How about 8%? 0.08. And what if you had 0.012?
That would be
1.2%.
How?
I'll leave it up there. 2 places. Look. 1, 2.
Oh, I got it wrong because I thought.
Okay. 2 places. All right. You ready for the next page? We good? We understand gas is going up.
Yep.
All right. Now this one is real life. I wrote this problem last night too. It's about Zach.
Wait. Did you spell Z-A-C?
Yeah. All right. Zach bought an iPod for $280. Now it's on sale for $220. Find the percent of change. Sorry, Zach. You got ripped off. Maybe you can take it back. So Zach bought an iPod for $280, and now it's on sale for $220. Find the percent of change. You notice that it's not going to say find the percent of decrease or find the percent of increase. It's just going to say find the percent of change. It's up to you to figure out what's going on there, right? So on a multiple choice test, you have to be real careful that you're reading it. Does it say increase or decrease? The number might be the same, but you have to know what's going on. So is this one going up or down?
Down.
And how do we figure out the difference here? Subtract. And then what should we put that over?
200.
The original. Good. You guys got this. I knew you would. So first we subtract. Then we divide.
You divide.
Yep. Just like the last one. So we have the change over the original amount. That's going to give us a decrease. We already said it's decrease. And that's 0.21. I did that one right. Oh, phew. Did that one right. So you subtract. 280 minus 220 is 60, right? So you put the $60 over the original amount, put that in your calculator, and you should get 0.21. And then 0.21, move the decimal 2 places to the right, 21%. 21%. Okay with that one?
Yeah.
It's the same problem, right? It's just that one was going up and this one's going down, but you do it the same. You still subtract, and you still divide by the original amount. Okay? You just have to know what the original amount is. If you can't figure out that the original amount is 280 and you put 220, you're going to get it wrong. So you have to know the original amount is the price you paid. Yeah.
What are you dividing? What number are you dividing?
Like how in your calculator? 60 divided by 280. So you always put the top number in first to your calculator. Okay? Top number. Okay? So far so good? These are easy, right?
Yeah.
Okay. So here's what I want you to do. Hopefully you have a calculator, or you can go grab one. In your notes, I want you to find this one. Find the percent change from 10 yards to 13 yards. And then I want you to tell me, did it go up or down? So calculate that. Write it down in your notes. This is A. We're going to do 2 of them, so A and B. So find the percent change from 10 yards to 13 yards. Put your hand up when you think you have it. Okay, Zach, what'd you get?
30%.
30%. Raise your hand if you got 30%. Good. So, what's the first step? We subtract. So what's 13 minus 10?
3.
3. What's the original amount?
10.
So what's 3 divided by 10?
30.
0.3, which is 30%.
Oh, I didn't add the 0.
Wait, it goes 30.3?
0.3 is 30%. Okay? So you subtract 13 minus 10 is 3. 3 over the original amount, which is 10. 3 divided by 10. Put that in your calculator, guys, if you haven't done that yet. 3 divided by 10, and you should get 0.3, correct?
Yep.
0.3 is 30%. 0.3, because we're moving 2 places to the right. 1, 2, we have to add the 0 there. It's not 3%. Okay? If it was 3%, it would have said 0.03, right?
Yeah.
Okay? All right, try another one just to make sure, because I think about half of you got that one. Try, oops, I didn't put the second one. It's all right, we'll try it in a minute. I have more. But let's look at this percent error real quick. Percent error. You guys heard that before, percent error?
Yeah.
You hear it around election time when they're starting to get in the votes, right? And they'll say so-and-so is up by 1.5%, but maybe there's a 0.5% error in calculations, right? You'll hear that. You'll hear it when they're estimating things, okay? So percent error is a ratio that compares the inaccuracy of an estimate or an amount of error to the actual amount. So it's another ratio. And if you want to put it in your own words, it's a ratio that compares the improper estimate, right? So it's like when I estimate that I put in 45 hours a week at work, and then I find out after I do a log that I actually put in 60, right? Stuff like that. Or do you guys ever estimate, you're like, oh, it's only going to take me 5 minutes to do my homework, and it takes you an hour?
Yeah.
Yeah. So that could be an estimation of error. Or you could say, I only spend 3 hours a week on playing video games, and then if we logged you, we'd realize it was 300 hours or something, right?
Manual.
We could figure out a percent error. Question?
Does it matter what number goes first when you're subtracting? So like 10 and 13 or 13 and 10?
Well, if you do 10 minus 13, you're going to get negative 3, so it matters. We're only using positive numbers.
But like, if you're doing a problem and they want you to subtract the smallest number to the biggest number.
It's always the bigger minus the
It's
small.
gonna be the bigger one.
Yeah. Okay, so percent error is what we're talking about. Here's the equation for this, which is very similar to the equations you just did, correct? You have the amount of the error. How are you going to get the amount of the error? Do you think? And how did we find the change last time? Did we add? We subtracted. Wow, we're going to do that again. And it's still over the actual amount or the original or something. You know, we did original, now we have actual. Okay, so we have this thing that's going on. It looks like our other equations. It's still a subtraction thing. And then we have an actual amount instead of original amount. Okay? Alright, so here, oh, too bad Logan's not here. I wrote this just for him. That's okay. He might be watching later. Hi, Logan. Alright.
Hi, Logan.
Hi, Logan. Alright, that's good. Logan estimates he ate 13.5 pounds of Halloween candy last year. But he actually ate 15 pounds. Find the percent error. He actually ate 15 pounds. Find the percent error. Okay? So we could change it. We could say Josh M.
Can you say Zach?
No, we already did that. Estimates he ate 13.5 pounds of candy, and he actually ate 15. Okay, so step one would be what? What?
To subtract.
Subtract. What's 15 pounds minus 13.5 pounds?
1.5.
Good, 1.5 pounds. What do we put that over when we divide?
13.5.
13.5, because that, is that the actual?
Yes. Yeah.
It is?
No.
15 pounds. So 1.5 over 15 pounds is the actual. Then you divide that. Okay? So here's all the steps. That's the one where I wrote something. So we have 1.5 because 15 minus 1350 or 13.5 is 1.5. And then we calculate that over the actual, not the original, the actual. That's where some of you might get confused, but you'll work it out. If I give you enough problems for homework, right?
Yeah.
All right.
I've got it.
Won't forget.
So 0.1 is not 1%, it's 10%. So you would say his error was 10%. Okay? Question? Yeah. Okay. So in your math books, this is the one I was saying you're going to do more than one. You're going to try these ones. There are 3 problems. You're going to try them all by yourself. Do not talk to your neighbors. You're going to try them. And then in about 5 minutes, I will call on you to see who has them. Okay?
Are we done with notes right now?
Yes. But you might want to keep your notes out so that you know how to do the math book. You might forget. You don't think you'll forget? You remember things? Okay, so try 146, 1 through 3.